We are talking about low latency. What threshold are we assuming? Is it about less than 1 second or less than 100 milliseconds?
Right. That is something to be like a more granular specification we may need. But
also I feel that there must be a threshold, right? We cannot, if someone goes into infinite loop, we cannot keep running, right? So we have this upper limit that if your solution do not pass under these constraints,
it's like that TLE thing, right?
And,
time limit exceeded.
Okay. So that can be saying, okay, if it's going for that async call where it's going to execute and run for the all test cases, it's surely going to get more than milliseconds. Right? So then that we can restrict with the return statement.
And one other question I had was, are we looking into, like, I have not participated in any Leetcode competition, but how does this work? Can the user make multiple submissions until they get it right? Okay.
You can make multiple submissions, and based on your multiple submissions, in some coding platforms, they rank you. If you do multiple submissions,
I see.
Then it might also not be a good way of doing it, right?
So in that case, how is I see availability part, right? It's a coding competition stuff going on, so it has to be available. But if there are multiple submissions allowed, right? And if we are trading off consistency, like how does, I'm thinking like if the user submits and he or she gets like it doesn't reflect the latest accurate result, and then it might just unnecessarily waste that person's time, right? You might just go back and try to fix that, and then you refresh the page and it's showing it's passed. So isn't consistency, like, although both seem important, but I'm thinking like how are we thinking around high availability versus high consistency here?
Consistency on your own rights, that should be consistent, right? So whatever you are submitting, for that you should be able to see it.
But that is correct.
But for others, like in the end, when you get a leaderboard, so even if it takes some time after the submission or after the contest is over, even if you get after 5 minutes, that's still fine. Right?
Time. I see what you're saying.
And when you are actually working on a contest, you will be given a 1.5 hour time. So at that time, whatever submissions they are doing, you will always get a result, whether it is passed or failed. That's the only thing you are going to get. You won't get your score. Your score will be calculated in the background. When the contest is done, then the scores will be matched. Or maybe you submit the whole thing. So there are different ways to handle that.
Okay. Thank you.
So then this has to be highly reliable. So someone had any questions on that? I think someone was trying to.
I was saying that why jump to consistency? We have not cleared even the requirements yet.
We'll do that. Shashank, you had something?
No, they are telling to record the session. So
go ahead. No problem.
Record it, right? It's fine.
Sure. For me, no problem. Someone said that we have not even covered the requirements. That is what you're saying?
Recording in progress.
Okay. So see, these are the requirements what I'm going with. Okay, very simple ones, and we can again revisit. So what I'm trying to do is first the user will try to register for a competition. That will be the first requirement. And second, user submits his code for a particular question. So there will be submission against each and every question. And then the user fetches a leaderboard, so to view all the scores. And the third, user has the ability to read the history also of different challenges, whatever happened. So these are the 4, and out of that, I think we might be able to cover the first 3. Okay, or possible then we go for the 4th also. So any questions on the functional requirement if you want to cover something else?
Is the history of a challenge or the history of a user?
Yeah, that's a good question. So it can be a history of a user, because that will be more important for us, right? As a user, we should know only our history, isn't it?
Okay. Yeah.
So that is what I'm thinking. But yeah, we can actually discuss on that front later maybe.
And this fetching the leaderboard will be after the competition, right?
Leaderboard, yes, because when everyone is done, we should have that, correct?
So I think Leetcode basically.
Most of the judges have a live leaderboard.
Yeah, they have a live.
Leetcode also has it, right? Immediately it shows.
Leetcode enables it after 10 minutes, actually. Like for the first 10 minutes, I think you can't see it, but after that, you can start seeing it.
Okay.
So basically, whenever the submission starts, so I know people start submitting very fast. So
I think that might be that's an interesting thing because that can affect the design pretty, significantly, right? If you're having periodically refreshes of your leaderboard, then you have to fetch the data, analytics, and all that. But we may take it step by step. Right?
Maybe. I didn't think on that really. Fine. Okay, that's a good thing. So then we discuss about these non-functional requirements: high availability, low latency, high reliability. And okay, so these are a few APIs. What I thought they might be a good thing to start with. One is, as I said, like we'll go for the first thing about user registration. So user will do a registration. He will have his user ID and the competition ID or the challenge ID, whatever it is, you can call it. Second will be submission of code with the user ID, question ID, and whatever language is choosing, and the code text. Right. So this will be the code text, what you're going to submit. And third will be just getting a history based on the user ID. And then fourth is about fetch leaderboard based on the challenge ID. So for each challenge, you'll be able to get this fetch leaderboard. And the third will be get the last successful submission. So whatever you have submitted, the latest one, you would like to see what it is. So user ID, question ID, and the language. Okay. So going in the same API, so if you look at the data modeling or maybe the tables, what I've considered and based on what I read through about this on that site. So they are using first is a users table. You will have a user ID and then you will have a name, date of birth, email, user details, and etc. And you will have a cumulative score here. So that cumulative score will be till date for all the challenges what the user have done. And then when it was added, the user was added and updated at. So this is very simple, but only user ID and the cumulative score is more important here. And if you look for the challenges, so users is a completely independent table. So challenges, again, it is almost independent again. So you'll have a challenge ID, name, and start time and end time. That's the only thing. So then if you go for questions, okay, so now the question slightly becomes interesting because you have a question ID and it is actually linked with the challenge, right? So each and every question, because we are actually considering about a competition here and not the Leetcode way where we have other questions also, whether they are a part of challenge or not, right? So in this case, each and every question is tied up with a challenge. So therefore you have the challenge ID as a foreign key here. And then you have the name of the question, maybe description, then the question text, the test cases, all linked to it, and the author and added at, and the editorial also, and the comments and the points and the difficulty level. Everything will be a part of the questions.
One question basically. So is a question a part of only one challenge? Can a question be a part of multiple challenges also?
I think so, no. Okay. The way it looks like, it is only tied up with a single challenge.
Okay.
Yeah, but if you want to add a different challenge, because the challenges are like on timeline basis. So once the challenge happened today, so we have all the questions for that, and then we move on to next one. So we might have a different question, maybe slightly tweaked. So it will be a different version, so it will have a different number. That is what I think.
Okay, so in that case, I think we need to have a mapping table, because if one question can be a part of multiple challenges, then it becomes a separate entity as question challenge maybe.
Yeah, right. That is the reason what I'm saying is that is the reason we won't have the same question, but it will be of some different number because it will be an enhanced question, right? So it will be a completely new question as per
different question.
Okay. Yeah, as per this design. But what you say is a good thing. It should be clarified before even we go ahead. Yeah. So that might be more complexity to add to that, right? Yeah. Okay.
So now it might be out of scope, but Leetcode does have something like similar questions. So maybe they have some pointers.
Yeah. So because
Okay.
what's the point of storing the same data again and again, because the same question is being referred into weekly challenge as well as bi-weekly challenge.
Oh, you mean to say the different challenges, right? Okay, the different
Yeah.
type of challenges. Okay.
Yeah.
For that, it makes sense. So you can act, but in that case, you can still pick up from the database this question ID, right? So only thing is, okay, the challenge IDs will be different. Maybe we'll have a challenge type also as a field in this question then.
Yeah, but should we ask the interviewer if we cannot ever repeat a question in the challenge? If that's the case, then we need that keep that record. Otherwise, we don't, right?
Makes sense. I think that should be clarified before we would do this. Yeah,
or we can isolate the questions, right? Like, so the questions need not be associated with the challenge. The questions simply have a question ID, and then we'll have a challenge to question relational mapping table.
The mapping table,
that basically says this particular challenge ID has these set of questions. So that way, whether a question can be repeated, it's still possible, right? Like, so we don't have to worry about the repetition and stuff.
Okay, so you are saying that we can have a mapping with the challenges and the questions table, and then we can have a separate table.
Yeah, and not tie a question to a specific challenge.
Yeah. Okay, so we could remove the challenge ID from here. Yeah. Yeah. Yeah, normalization, correct. Yeah. Okay, so now the submission. Go ahead. Questions.
No, but does that happen? No, but does that happen in a competition also?
No.
Yeah.
Otherwise,
right now, yes, but that is also a good thing to put up somewhere. We might have topic-based questions, right? Yeah.
No, but that is.
You will know the answer. You won't know the answer if topic is given.
So
I mean, you will get the hint.
Yeah.
That is also a good question.
No. I think we might be. Leetcode is a big platform, right? There is competition aspect. There is general, practice aspect. I think we should separate that out. And from what we are seeing right now here, we are leaning more towards competition right? So maybe
don't mix the Leetcode platform with this, right?
Yeah, because that will be a very big scope.
Yep.
I mean, Leetcode is one example, right, which supports that, but let's just narrow it down to competitions.
Yes. Yeah. Okay. So then this is the submission table where it goes for the submission ID, where when a user is submitting his own solution. So it will have a user ID and also the question ID, the language, what he's using, and the submitted code and the score. When he submits, it will actually return back the score and what time it is created at. So this will be one table, and the other will be the participation or the registration.
I think number of submissions should also be there. How many times you submitted the same code to reach to the correct result, right? That also takes into consideration.
But I think, like every time you do whenever you do a submission once, that will be one submission ID. If you do multiple, then you will have different submission IDs. That is what I think.
Yeah, but score will be reduced in that case, right? If it is not correct, I mean, if multiple submissions you make in order to reach to the final submission where all the test case passes, right?
Yeah, so the score,
reduce the score.
So the score is based, like if my submission is like fails, right? Some test failed. So will it have a score or will it not have a score? So score basically, is it based on success or failure? Like, or it is just
sometimes, they even consider if you have a partial success, because in some cases, you cannot pass the time complexity of O(n) square or maybe O of n, then you do it O(n) square. Still, you are able to only pass some of the test cases. So in some competitions, they even consider those scores because you have to rate the person individual like that.
Okay.
So yeah, it might be possible. Yeah, but Shashank, your question, I was thinking like we'll have a different submission ID always, and we'll have a different score for that person. But when we are actually totally, scoring that particular person for that particular competition, we'll have to consider all these submissions. So that is what I'm thinking. Yeah, something like that.
So score can be part of submission also, right? So once we calculate any submission it is submitted, so we are calculating score on that, and we are saving it. And the last leaderboard score or the user score can be the summation of all the submission scores that are like, or some logic.
It's almost like a cumulative sum idea, right? We are maintaining the score, and if you do an incorrect submission, I think somebody had mentioned that you can penalize and deduct some points, and for a successful one you keep adding, and
yeah, that's right. So I think this score is for an individual submission of a particular question. But then if you go for this participation registration table, you will have a participation ID. So you will have a user ID, challenge ID. So that score actually will be an aggregate of all the scores what a user has submitted for that particular challenge. So that will come here, I think, and then whatever the accepted submissions are. So these will be the number of submission counts, what has been done for the user. So this table will be helpful in evaluating all the leaderboard. Okay, and also every user will have its own cumulative score, the overall cumulative score for all the challenges till date. So that will be in the user table. So now if you look at the estimations, okay. So estimations, they are, go ahead.
Yeah, so participation ID is like a user can have a lot of participation IDs based on, they will be like challenge related to challenge IDs. Is that what the relationship is?
So yeah, so you will have participation, you will have many users actually participating for a particular challenge, right? Okay. So maybe like 30,000 users are participating for a challenge ID. So there will be 30,000 users for just one challenge ID. Therefore, you will have user ID 15,000, and then you will have one challenge ID. But you will have many challenges also, and many users have been participating. So this table will be a huge one.
And so this will help in calculating as well.
Yeah, the leaderboard calculations and all the things will be actually done by this table. That is at least I could get from here. Okay. So now if you look at the estimations part, the total number of users, it's not heavy here, right? It's like 10,000, and they said, okay, just cap it to maximum 1 million. But I think this is also too much. And the number of users registered for any competition, if you see, it's like 15,000 here. So you will be saying like if user performs 10 queries per competition, so like the submissions, if it does around 10 or so and reading and everything, so it will be 150 queries per hour, and so it can be 2 queries per second. So all these, I think they are talking about the read, right? So 2 queries per second is also not a big thing. So this can be easily handled by many of the modern servers. And
are we dealing with rate limiting also on how many submission a user could do in certain amount of time?
Frankly, no, I never thought of that, but that will
no, yeah, we do. I think at least, I mean, again, we are going to Leetcode, but basically it would help not someone overwhelm our system, right?
Agree.
Because this is competition, so this is required, I guess. I don't know.
Yeah, you should not submit within a second at least, or maybe more than that.
Yeah, another thing is
normal. You're good. I mean, they say that your code is submitted too many times within given time frame, right? At times you repeatedly submit the code.
Yeah, so that is what they're saying, like the rate limiting will help there, right? Yeah, I agree.
Yeah, so another question with respect to data modeling is, right? I mean, this is a competition and multiple users are participating from different countries, right? Or you are like just establishing this competition for one country?
That's a good question. I think it should be all across the globe, correct?
Yep.
If that's the case, then how are we dealing with like, where all the user database is stored? I mean, is it replicated across multiple regions, stuff like that? And because we need to deal with latencies in this case, right?
Yeah.
Because
I never thought about that also when I was reading through, but that is a good point. So in that case, we'll have to share based on the geography also, is it? Maybe, yeah. Okay, we'll come to that later when we are actually done with at least. Let us assume that is going to be only for a certain region now, and then we can see how we can accommodate that requirement. Okay.
Yeah, so that question is like, I mean, I don't know, whenever I do some sort of design question, that always comes into my mind, that how you are actually going to deal with this kind of situation. This is very tricky.
Right.
We should discuss that.
Because if you do it region wise, then it will surely have other problems also.
Yes.
Not only
yes,
about the
yes.
data, yeah, the leaderboard also, everything. Yeah.
This is always a cycle for some reason, I don't know.
Yeah. Yeah. So now if you see the data stack, well, here, right? Yeah, you can assume that maximum 10 queries if you're performing. So you'll read also, right? So it will be a read and write, maybe. So maximum if you do 10 submissions, if you do 10 writes, maybe if you just consider that way.
So
and if you do read more, it
we...
will be fine, right?
Oh, 10. Okay.
It will be for results, as well as you want to again view the question what you're looking for, something like that, right? I don't know. I'm just saying 10 queries. I thought the 10 queries are more important from the writing perspective, isn't it? Because we are just submitting it. Well, yeah, it will be read for, it will be write for sure, right heavy in the sense when we are executing code, when we are submitting it, and that for that competition, at least it will surely be a write heavy, right? But reads are also going to be there, but only the same number of users are going to be reading it. So I would say it will be more of a write heavy, but the ratio is not going to be too huge, right? But yeah, anyone can discuss on that.
I think one point to consider there is, if we are thinking about real time, like periodic refreshes of leaderboard, right? That every time you make a submission, you're able to see that. Then you're also doing a lot of reads, right? Every time people are submitting code, that analytics has to run, data has to be read, and it has to produce results, right? But if I think in our problem here, we have scoped it out to be at the end, you see the leaderboard, right? So from that perspective, it seems to me it's more write heavy because you're focusing more on writes. But I think this is something we can maybe brainstorm, use one of this, like how is leaderboard presented, right? Is it periodic? Is it at the end? To me, that's where reads are going, right?
Yeah.
That's
so let's go.
Even I think like sometimes it's read heavy because like it has to compare the results, right? It has to compare against specific results.
Oh, right. Yeah, it has to compute that.
Yeah.
Do that.
It has to compare the results because like it can compare like what the user has written. It only can compare the output the user like
true.
I think like it otherwise like, it should show all the test cases.
No, I was thinking.
So maybe we can say, okay, leaderboard is done at the end for now. Okay, let's not mix that. So we just consider it is going to be, we are just submitting it for the competition, and at the end we do it.
And one other question I had, more generic, not specific to this. Whenever we talk about read heavy, write heavy system, right? I think I sometimes get confused because there are two ways to look at it. One is read or write heavy with respect to APIs, right? What client is submitting. If I'm trying to refresh and check the leaderboard quickly, periodically, then it's like a client request, right? That's a read request. Versus if, let's say, we are going with the current design where leaderboard is at the end. Now the system behind the scenes is scanning maybe data, periodically to have the leaderboard be ready quickly at the end. So that doesn't count as a read request, right? That's a different case. Like, but I'm thinking, like, when we talk about read write request, what is the context we are looking at? Is it the client request?
The way I think is whenever request hits on a application.
Okay. So
that is so it seems to me like that. But when you are saying those things which are happening at the back end, that should be some processes which are actually they have the access to all the data stores, right?
Correct.
So they don't have to come through all the network and all those things, and again coming through the load balancing and the app server, right?
No, yeah, sure. That's true.
So that is all the internal things on the internal microservices. Yeah. So that is my thoughts about it. But yeah.
I think that might be the next step, right? I think he's just presenting the high level.
I'm not sure if the client.
Yeah.
I thought this should be more of a. Do we send the code to run somewhere, or is it on the client? We run the code.
No, we send it to the server. We don't run it on the client.
Okay. It's a HTTP request, by the way.
Okay.
And the content is GG compressed.
Okay, got it. Thank you.
Yeah. The payload is language, question ID, and typed code, which was one string of your entire code for the submit post request.
So anyway, see, if you're saying that our code has to be secured, we want to have a compression or all those things, right? So the compression is only if the code is so huge, right? But so do we have so huge codes in the competitions? It's like maybe a A4 or two A4 size pages, maybe like.
No, I think
1K
it is
maximum loads.
Line of 100 lines.
Yeah, so the smaller the payload is, the faster it is to transmit it. So I think that's what they're trying to do.
Okay. So in terms of HTTP request, right? Okay, makes sense then. Okay. So the second now about the data size. If you just look at how the data size is based on all these user tables. So user table will say it's having about 300 bytes, and that is what they calculate based on all the fields. And just believe me, that is what it is now here. So I don't want to go in details of each and every field. So for that, like if we have around 1 million users, so it's going to be around 300 MB. So now we are just calculating all the data size here. So for challenge table, it's going to be around 200 bytes, and it will be like if you have 10,000 challenges maximum till date, so it is around 2 MB. Okay, so roughly like that. So questions, it is about 11 KB here per question. Okay, it's going to be per record, right? Yeah, so it will be that. And so if we have, say, roughly around 50,000 problems solved till date, that is huge. So it's around 600 MB. And then the submissions table, each and every submission takes around 3 KB of data. So maybe around 6 MB for an average user who tries 4 times and all that thing, and attempts around 500 questions in his lifetime. Okay, so that will be around that much of the data. And now actually, if you look at all the data tables, they are not so big, but only for the participation it increases because it has a relationship with others. So if you have 15,000 participants per challenge, and so the challenge table is 250, correct? So 15K multiplied by 250 with 3 KB, because we'll have a submission, right? So, and if you have 4 submissions per person, therefore 3K into 4. So this comes to around roughly 45 GB, which will be a dominant one actually, considering the data size. So roughly we look at around 50 GB of current storage. And so therefore, if you look at all these data, it seems to be, it's not a big thing, because our relational databases, usually if they're lesser than a couple of 100 GBs, it's easy for them to handle that load, right? So that is what they are tending towards. Sorry?
I have a question. So we are submitting code. That's a file, right? That's some bytes of file, I guess. Are we using blob store, or we are storing the file compressed in our system itself?
You mean to say storing the file as a blob store?
Yeah, I mean, are we using some kind of blob store to store the file, or we are compressing the file? I mean, some bytes format and then using that inside in our system itself.
Here we are not doing anything like that. We are just actually, whatever it is in the text form, we are just storing it.
Okay.
So there's nothing done like that and no blob storage. It's a very simple text file. Whatever we get, we just store it in the table also. You can see it somewhere in the questions, I think.
Yeah.
Right?
Submitted code.
Submitted code.
But over the time, the size will increase for the DB, right? What are we doing regarding that?
So see, I was. If you look at these calculations, till now we had about 15,000 participants, and we had around something like 10,000 challenges, right? So that's a huge one. So if you look at that, and I think Leetcode also doesn't have that many challenges till date. So for 50 GB per 10 years or maybe 5 years, it's enough data, and that can be easily handled. So just to get a high level understanding of feasibility of how much data storage we need, we just coming to that.
Leetcode
it's a rough estimate. It might be more or lesser also.
If the type is text, right, in the SQL column, it is stored out of row in data pages, and the row will just have a pointer.
Okay.
Type equal to text. So whether it's 1 byte or 2 GB, it doesn't matter.
Okay. So you'll have a separate.
Yeah, this is what it's saying on SQL Server will always store the text type column out of row in data pages.
Okay, so that is the reason that won't be considered here, right?
It's kind of document based, right? I mean, a separate field you'll have for which a dedicated table will be there, right?
No, but a document database goes very different.
Yeah. The SQL is handling it. If you say the type is text, right, instead of varchar, you just say text. So it's automatically storing it out of the row and somewhere else, and storing a pointer in the row.
So that is what happens in your NoSQL, right?
I think so. Yeah. So.
I have doubt like how SQL is handling that. Then it might be a foreign key, something like that, corresponding to each user, and they'll point to that another table. I mean, let's see.
Yeah, that's a good point. Okay. So on a high level, this is the high level design. So you have this client, okay, web browser, and then we have a load balancer. We have different app servers, and all of these app servers, they are stateless, right? The servers will be stateless. That is what it talks about. And so anyone can handle any request. So this is a data layer wherein all our data about this metadata, what we talked about, that will be stored in this database. And we'll have a cache also. So we will cache a lot many other stuff. And then this is a submitted code execution layer, what they talk about. So what happens whenever we submit a code, so it comes here and then it is given to this text case executor or some module, which will actually run some separate containers. And these containers will be running isolated in a sandbox environment. So whatever we compile, if the code is not good, it's going to harm the system. It won't harm because the containers will be isolated and they will run whatever the code in that and execute against the test cases in that special containers. So it's going to be more secure. That is the way it will be executed. So this is what the model everyone uses. Most of them use, I won't say everyone.
Santosh, sorry, how many submissions do we have per 1 second?
Do we have 1 second? That's a good
question. How many submissions?
It is almost the same thing, like the 2 queries per second will be the submissions per second.
Okay, so just 2 submissions per 1 second. Okay.
Right, because if you have 15,000 participants and then 10 queries they are submitting per computation, and this 150 queries are per hour, so it roughly comes around 2 queries per second. Right, so that should be enough if you have multiple containers to handle that, right?
Yeah.
And not a very heavy load system, but yeah. But it's only about the test case executor or whatever the compilation, everything is done in a separate container sandbox environment. So that is the only different part of this whole OG systems. Okay, so they talk about some of the things like what it is. A user communicates with the application via web browser. Multiple application server that query data from the data store to distribute the load. Right? That is why we have multiple replication here also. And then all the servers are stateless, and the load balance is more simpler. It has just to distribute the load. That's all. And the data store will just store all the metadata of the user completion, questions, and submission, and all those things. And the CPU intensive machines run the submitted code against the pre-configured test cases in this test case executor. So therefore, they use containers for that. Okay, and therefore, you're looking at the database, the size is not huge, and we can easily handle using a SQL because it's more structured. And then if we go for different things about getting the scores based on the participation, it will be more easier to do. That is what I think, So therefore, they have finally on SQL here. MySQL maybe, but SQL database.
Hey, test case executors are sharded, right? I mean, which language? I mean, based on language, I guess.
Yeah. So see, a container will actually, it will be configured based on a language, isn't it?
Mm-hmm.
So it will have its own environment. It will have a separate, maybe a Linux virtual machine, something like that, or a Windows virtual machine. So then whatever compiler we are setting, so it will just set that compiler, it will compile according to that, and then execute all the test cases which it can point to that particular question.
Okay.
So yeah, so there's no need to sharding because yeah, so any container should be universal. They should be able to execute any of those, right? So just based on the configuration, so the container has to be configured that way. That is what I think.
So if it has to just run the code, it can be Lambda also.
What's that?
Amazon Lambda.
Okay, I don't know about that. Yeah, you can actually
yes,
that.
it can be like, but it just depends. Like, and
Because
Lambda gets
stateless.
expensive, right? True. But Lambda can get expensive, so you need to be very, very about the cost. If you're okay with the cost, then it's fine.
Like AWS Lambda and EC2, like the EC2 servers are more expensive than AWS Lambda. So,
Lambda is more expensive because fully managed.
No, it's not about that. Like AWS Lambda only gets provisioned when when it gets triggered. Like, so that's why like we use AWS Lambda. Like, it depends on the architecture as well. Like we can use AWS Lambda as a microservice instead of like in EC2 running on EC2 servers.
True.
But it takes some 30 seconds time to boot up.
Yeah, it does.
Depending on the
so like when you have to scale, so it is not good for a spiky traffic load, right? If you have a constant high traffic load, then probably again Lambdas are fine, because if you have a spiky traffic, you will have some latency there.
Yeah, I think it's around 1 million requests per second or something. Like, but at first, like users will see some delay, like because the Lambda container it has to start. So that might be one of the trade-offs. But
so how I solve that problem on my services, I kind of knew what my traffic is, and I used to kind of keep my Lambda instances kind of warm.
Oh, okay.
Yeah.
Sort of like starting from every time like there's a request, I understand.
So one question.
Sorry. Yeah, regarding this Lambda, so can we have configure like one at least one container or for the Lambda that would be running?
You have to keep them warm because they are managed.
Okay.
Amazon will shut them down if there is no traffic coming to them.
Okay, so we can configure that minimum one or something like that, or like that.
No, so we keep on sending such kind of like a heartbeat thing that doesn't do anything. It just hits the Lambda.
Okay.
Yeah, and then we know at least one of our Lambda is always alive, and then if any request, because this is like a collision detection service. So if someone is in an accident and it takes time to heat up the Lambda, it might be not so good. So yeah, so we wanted to make sure that, and we had a spiky load, right? So yeah, thankfully people are not getting into collisions all the time. So, but there can be like 5 requests during evenings or during weekends. So that's kind of a spiky load we had.
One question I have there is, let's say you talking from the interview setting perspective, right? Let's say somebody doesn't know about like AWS has a lot of technologies, right? So if you have some knowledge into it, that's amazing. But if, let's say, if I don't know much about Lambda, right? I don't want to bring it up, then talking from the first principles, right? Like we said that, okay, this test case executor has to be sharded. If we shard it based on language, for example, so we have one environment set up for Java, one for C++, and so on. Do you think a more generic question, can lead us to, like, if I have one environment for Java, sort of how to manage the load, because there might be a lot of submissions coming on Java. So things like, more derivations of general principles rather than specific technology stack.
Yeah, even generally speaking, sharding based on tech is going to be unbalanced load, right? So sharding based on Java or Python is not a good idea. Yeah,
correct.
So we'll have just machines, right? So every machine should be configurable. That's what I think. Isn't it? It should be based on the number of participants, how much we are and how many are going to be executed.
Yeah, but I was saying that if we know the sort of, I'm thinking like, is there some room for dynamic rebalancing, right, of load? Because the load
can you can always scale up if you have generic instances which run anything. You can always scale up, right? You can say if my CPU threshold goes more than 60, just add more. Yeah.
Okay.
Yeah.
One suggestion also. So if we are sharding on basis of tech also, so what is a problem? If more Java is coming, so we can have more Java instances, right?
We can scale selectively. Yeah.
So in that case, I think, I won't worry about that.
It's because not Java instances, I guess. I mean, it can be a plain, it cannot, it can even be a plain server where the server.
I don't mean Java instances mean Java. Yeah.
But
it would be Java processes,
whatever.
I would say.
Yeah.
Yeah, for me, I would
every time you launch a process, you execute that, and then you get the result of the process and you save it into the store.
Yeah, but I feel there'll be a lot of upscale and downscale, like, you in your system. If you have such kind of, that's just my way of looking at infrastructure, that I try to have generic instances as far as possible.
But I would say there will always be. Sorry, go ahead. Yeah.
Generic instances in particular, I feel have problems. Say, for example, when you run Java, right, JVM takes quite some time in at least warm up and, executing the code, particularly while Go or C++ or C, they are fast enough. They could they could handle double the load in that particular point in time. So generic is I don't know, but this is my opinion. Based on my experience, generic is not a way to.
No, so how I see this working is, you do not start, you have this kind of a readiness to an instance, right? You do not start serving traffic to an instance unless everything is working. So all your API should say, okay, I'm ready, right?
Okay. So in order to add to that one, so what I'm thinking is, it's a kind of a pool of runtimes that you have. You just assign them, and they do their work. And
Yeah. So we'll have that something, an abstraction layer on top of that, right? So this actually layer will take care of all the management, isn't it? So how it is going to be managed, that will be a big topic in itself, right?
Yeah, so basically you push every event, and then, I don't know, some work.
Yeah, in a queue, and then, but I feel we need to be very synchronous, no? Or it can be asynchronous, I don't know.
This will be asynchronous calls, right? So we'll have a queue for sure.
Oh yeah, okay. Got it.
And we don't care how much time it takes to return back, as long as it is returning back and putting the scores, right? So that is what I
don't know. Queues can, okay. I feel with queues that it can keep on re-queuing the message if something is not working, but it's okay. Like if someone is getting a late result after submission, it is acceptable, right?
That is what I think. But yeah, what you say is also right. When you submit something and you would like to know the result before you proceed to the second question, correct? That is also one thing. You don't want to just leave it like that.
So here with queuing mechanism, there is another problem. You need to return back the result to client. Now, when you put queue in between, right, you fire and forget.
Okay. No, there are futures, right, in languages now. So they will wait. Yeah.
That kind of execution. All right, fine.
Yeah.
That's visible.
Yeah.
What was that? You said futures?
It was already probably in Scala. Java took it recently, I would say from maybe 8 or 9.
It's a promise, so you can, right? Async promise.
Yeah, it's a promise. Yeah. So you basically say, just don't block this thread, if and keep on doing the other task which you want to, and whenever the result will be returned to me, then I'll proceed on doing this task.
Yeah, just inform me when the results return, and then
I'll proceed with the next ones. Yeah.
Okay, same concept.
It's kind of routine to Golang.
I think that's again a pressure on OS. I think in Node, and you have single thread, they take most of the threads from the OS, isn't it? And then they multi-thread. Although Node is a single thread, but still it behaves like a multi-threaded application. Why? Because of the threads it is taking from the OS, isn't it?
Right. But Node has an event loop, right? So it's continuously checking. So how is Java knowing that the future is complete? Is it also continuously checking?
It won't fall. See, it will be all event basis, right? So this will be event driven.
Okay.
Most of those servers are NIO based, so non-blocking IOs. So the request comes, and the request would be taken as from the separate threads would be taken, and it will give it to some other second layer of thread pools. And once the response available, the thread which has submitted the request would give it back. So there will be no blocking of threads because of the request. So the multiple requests can be processed. That's how Nginx and other stuff.
So the new thread will directly give it to the client, or he'll give it to the original thread?
No, it will give to the next level of thread pool to process it. So one level of thread pool will always takes the request and give it to the thread pool, the next level thread pool, and even that first level of thread pool will basically collects the responses also after the results have arrived and give it to the server back. I mean the client back. That's how NIO works. I mean most of the servers nowadays I think are NIO based.
And anyway, in this case, we are always connected to the server for the whole competition, right? So we don't need some other notification method to notify us.
No. It's within the server internals. NIO is server internals. How server is implemented.
Yeah, that's right. Okay, good. So moving on to.
But if we don't think as a container, we can think it as a REST APIs, which takes the request of executing some Java code or Python code, right? And what it does is that code will simply launch a process that can be done. I mean, using a process APIs every language has to launch a process. And once the process returns something, it will give it back to the client as a REST call, whatever response it gives, right?
Yeah,
we can think that.
This is right.
I mean, if at all container was not there, that would be the way it would have been implemented. Right?
The container comes into picture because it has to be more secure, because someone might write a malicious code, and that even if you have a process, you can still go and.
So we have timeout, right? So that's why timeout, right?
Yeah, it's just for the timeout. But if someone actually tries to get into resources of some other process, by this code.
some
It
kind
might
of
be
a
a
DDoS attack you are talking
Yeah,
about.
yeah. So therefore, they are actually talking about all the sandboxing. That is the main actually in those OJs.
But even there, some kind of a timeout has to be employed by the process. Like if process
But
is
if
not
it's
that
a
will
C
be there.
program and it's accessing the memory outside, it's allowed.
I feel instead of
Processes you should
every
be able
time
to.
launching a new process, there can be something like a process pool where a set of processes will be there and which is already started, which will be keep on running, and we give that task to that process. Something like a server process, right? We always process always keeps on running. We give
But we have to
something to
compile
it.
the code, right? We have to compile the user's code and then run it.
He's saying that you have another process for a compiler also. No?
Okay.
Something like that. So then you keep doing that. Maybe possible, but then we'll have to consider everything, or maybe
I'm just thinking in terms of general load balance and REST API instead of container. I mean, having a container oriented thinking.
And also you have nothing on that server, just these things executing, so you don't bother about the security, right? Even if it crashes, it's going to crash the other participants' code. But then that will be a bad experience, right? User experience. That is also a problem. We have to protect our users also who are actually more focused on working, and we don't have any other problems with the users. So then right?
I have a question, Santosh. So in these kind of a scenario, in these kind of systems, do we save the submission in the database and then give it for execution to maintain the reliability? So for example, if the container goes down while I've made a submission, so should I save my submission first and then evaluate it, or how does it work?
I think that is a very good point. I would say first submit into the submission table, okay, all the code.
How will we get the score?
And when we actually submit, then we'll get a score.
Yeah.
Right. So then I'll have to go and update my submission table again.
I think it is almost like, to me, I am drawing an analogy with in general the way WhatsApp does, right? So if you think of three entities, right? You are a client or a user submitting your code here, and then there is you get the not the notification, but your code is submitted, right? When it says judging or something, and then you get an evaluation, right? That's the result part. So I'm just drawing an analogy with WhatsApp. So client sends a message, and then you get delivered notification, and then you get the read notification.
So
right?
Okay, so as per you, there are different states for that submission that happens, right?
So I'm thinking like when. So I'm thinking like, sorry, go ahead.
No, please go ahead.
No, I was just saying that maybe like once the code is in the, it's submitted, it's in the assessment process, right? Depending on if a container is down or something like that, I know at least the code is stored, right? I can store it in a queue or something. I have to make sure that once the client gets the thing that, okay, it's judging, right? I know it's submitted. So it should be durable, right? It can't get lost. But once it's evaluated, I think then, depending on requirements, I think then it doesn't need to be saved anymore.
Okay, so my follow-up question on that is, if we are storing first, then I can enter whatever garbage values in the submission. So we will be storing them as well.
What do you mean garbage value?
Like I can write anything random, not code or anything. So we will be saving them as well. And it would probably fail at the compile stage. So do we come back and remove those entries?
I think
that
so.
is a good question. We should actually, because I think we talk about such user. We need to identify, because they do for the plagiarism, right?
Right.
So that if they can do it, then we should be able to do for these users also. We need to stop these users for actually writing this code.
I see what you're saying.
So should we have a filter whenever a submission is made? Should we have a pre-filter where it just at least compiles?
Yeah, we can have like different, you're talking about now multi-level evaluation, right? Compile time.
Like an eligibility filter for the system to even accept it.
Yeah. Okay.
That's a very good point.
Compile we are talking about, because there is something I think most of the systems have run taste or something like that, and then there is something submit, right? Those are different. I think it comes in Leetcode and others.
Yeah, I think
so. Compile happens in the run test, and submit is a different option, like where it will go and test on internal more test cases. Suppose just compile happens on 2 test cases, and submit will happen on more complex test cases, and it will calculate the performance of the code on different large data sets or like that. So we are like when someone is going for submit, so that means that code is like passing the first
it's functional
initial phase. It may be wrong in large data sets, but it is passing the initial one.
I think the main takeaway, the way I'm thinking about this is like thinking of it as a multi-step process, right? Like you're having stages, and you said.
But every container is kind of it has to maintain certain kind of a state, I guess.
No, container, I think it's going to be only just execute, that's all, and just set the result.
No, while executing, see, let's say, which test cases are passed, which are failed, what is the result of that?
So whatever it gets, it's just going to return the result, that's all. And then that has to be taken care of.
Both way, I think, sorry.
So you mean to say it's not stateful, it's just a stateless, and we can horizontally scale?
That is what I think, because they should be, right? It should be stateless, the container.
But eventually state about the result has to be stored in DB, I guess.
Yeah, see, whenever I get a submission, okay, I know what the submission is. I store the code of the submission in my submission table, okay? So then I go and I know that the second thing what I have to do is I have to submit it to the text executor. So if I submit my code to the text executor, the container is going to execute and return the results. And then when I get the results, I'm going to I can store that code in my submission table for that particular submission ID. So that will be one simple task I have to do.
Okay. So there will be, let's say, 100 test cases. For each one, it would be running the code,
based on
all the results somewhere in the container, and then finally it has to give some file pointer or something, right? No.
So the test case, actually, the way I look at it, if you have 100 test cases, so based on how much test cases it is running and how many test cases it passes, or if it passes for all of them, so it is just going to get one score, maybe a simple number based on 0 to 100. So where it actually lies, and that number will actually be written to the DB. So this will be only for passing test cases. So if everything is passing, it will still maintain a score from 0 to 100. So, and if it is not passing, then it will have a different way of doing it, but it will just have a number. That is the way I look at it.
Okay.
It's not trying to store each and every test case, whatever the details are, because if you look at the table, they are very simple. But yeah, what you say, we can add all those complexities and we have to make it, because when we want to really judge for the contest, we have to look for many things. It's not only this. Yeah. So this complexity will surely increase. But for now, on a high level, it's very simple. Yeah, but then there are a lot of questions coming up, right? So things will be more complex for sure. And it's not that easy also the way we look at it now. Yeah, I agree. Okay, so I'll just move ahead. Okay, so this was everything, and then they talk about something very high level. They touch base about all this stuff. Okay, before going that, I will just quickly run through all these APIs and so whether they really satisfy the way we were doing it. I just want to go to that. So now if you look for this first API, when we said register user, so register user, what it does is it will have a user ID and a competition ID. So what actually I think it does is it goes to this participation table, okay? And then in the participation table, it will go for this user ID and the challenge ID. So this is where actually it just registers itself. So it will use this table only. That is what I look. So at least this API, it just looks for this table and it stores its information. For the submit code, if you look at it, you have a user ID, you have a question ID, and the language and code text. So it will use this submission table. Okay, it will go to this user, for that user ID, for that question, it will submit all its information. And that is what this submit code API will do. Okay. But yeah, after that, there will be other things also what we discuss. But only the initial thing, what will happen and how it is tied up with the data model, I'm just trying to go through. And then the get history, actually it goes to user ID. And actually in this case, it will go to the challenges, I think. No? Because for this, okay, so no, for guest history, actually go to the submissions table. For that particular user ID, it will get all the submissions, and then based on the questions ID, it will go to the challenges. Okay, and from the challenges, it will go to the participation table and find all the details of that particular user and return as an history. Okay, maybe, or maybe just go to the participation table for that particular user ID and then get all the history of all the challenges what happened. I'm sorry, yeah, it might be doing that way. And for fetch leaderboard, actually it will go to the, okay, so this becomes slightly interesting. It will go to a particular challenge, right? Okay, I think it is somewhere below. So for a particular challenge ID, it will still go to the participation table. It will go for that particular current challenge because the leaderboard will be only for the current challenge. And then it will get all these user IDs and all the scores based on their descending order. It will rate all of them. Okay, so that will be the leaderboard API.
So Santosh, one question. I have one small question. So I see a score at a participation level, which is associated with the challenge ID. Okay. And then I see a score which is in the submissions table, which is associated with the question level. So in a challenge, there could be multiple questions. So here, the score in the participation is the score of the complete challenge.
Yeah. Yeah.
And the score in the submission is the score per question.
Yeah. So this actually score is per question. So, and then you'll have many questions per challenge. And then those will be, some way maybe compiled in such a way.
Okay.
That score will actually be tied up with the challenge ID.
So will the participation table score get computed after the challenge is over?
Yeah. Yeah. So that will be some process doing all that stuff.
I think that's the requirement we are going with.
Right.
I know, like we were talking about earlier, right, that you can do periodic, but that's not out of scope for this discussion.
Yeah.
Okay.
Yeah.
So for periodic, then it will be a different altogether, right? Yeah. So if you look at that, now the scoring mechanism, so what they say is, in some cases, you'll have to even find out the time spent after a problem was opened by your user and before he submits. So how much time he has spent on that. So those also will impact your scoring. Other than your actual scoring of the test case execution, these things are also taken into consideration by some of these online judging systems. And then the partial scoring also is taken into consideration. In some cases, even if you submit an O(n) square solution for O of n, still you are giving some score. Still you have to be rated. So that is why these things are going to have another impact on your score. And the number of incorrect submissions also. If you give more incorrect submissions, then it's going to have a negative effect on your scoring. And then multiple submission of correct scores will be updated in the submission table, but that might also have an impact in a positive way or negative way. It depends on the judging platform. So based on all these things, so I think, if you look at all this stuff, it makes more sense to do at the end of the contest. Right? Or if the user terminates himself saying, okay, I'm completely done with my session. So at least for those users, you can rank them, but that ranking will be still in a transit state, right? Because you might find some better users coming up based on, even if you consider all these other conditions, there might be more also, right? So things might be more complex. So that is the reason I was thinking about it is always better to have that leaderboard at the end of the session, but doesn't look like. And okay, so this is one very simple way of looking at the leaderboard. You do a select query on a participation table, where your challenge ID will be your current challenge, and you just order by the descending. So this will be a very simplistic way of doing it. So you will at least get all the leaderboard, but then you will have to take into consideration of all these other parameters also of scoring it. Okay, and then you can tie up with your cumulative users, whatever the cumulative score you have in your users table. So you would like to compare that also in some cases. So that is one thing. Okay, so now if you look at the other stuff, caching, they say you need to do caching for leaderboards because many users, at least for that particular, when the challenge is done, we would like to get those results and read it very frequently. So that will need to be cached. Set of questions for a challenge has to be cached. Then the profile of an active user, I don't know whether it's really needed, but fine. And active user score history, maybe, and get practice problems sorted on a difficulty level. Yeah, but this is not actually for our scope anyway, because we are not targeting that scenario. And so what happens if a machine fails? So all our database actually has a master slave architecture. So reads are done by slaves and the writes are done through master. Okay, so even if it fails, then the slave will be actually pushed to master and all that. So that will be taken care of. And data is like less. So a single master without sharding is sufficient. But someone discussed about that saying, okay, let us, if we go via different regions, then that might be a other thing to take care of. Okay. So yeah, so these are the some.
Replication won't be there over. I mean, I didn't understand that point. Data is less to single master without sharding.
Yeah, so we are saying that because the data is not huge, right? So when the data is huge, then we want to actually shard it, isn't it? So
yeah,
the data
sharding,
is very small.
Yeah, but I think sharding, like when we talk about master slave, that's we are talking about replication area, and then sharding is another section, right? Like it's a totally different context here. So
partitioning, sharding is partitioning.
Correct,
right?
Exactly. But I'm saying that replication and partitioning, you can't mix them up, right? You can't talk about them in the same. Like they go together because of the looking at the scale of data, but they are two different concepts, right? The moment you talk about master slave, right, you're talking about, I mean, depends what. All I'm saying is I think we should separate them out. Yeah. Because when you talk about master slave, suddenly there are so many other areas that come into picture, right? So.
Yeah. So actually, you're saying.
Yeah, and especially, and one other thing just to mention, right? So since we are talking also about a write-heavy system, right? There are a lot of submissions happening. Something to talk about is, like Santosh you mentioned, right? If master fails, you can, pick up something from a list of followers and do that. But I think one of the other things to take care is when you're having a write-heavy system, and if like think around single leader, like single master, what you talked about, but your writes can suffer in that. So you might want to think about having multi-leader approaches. Like how would you scale your writes? Because in a typical master slave, it's mainly about read scalability.
Yeah, I won't worry in this case because the way I am thinking is because we have only 2 queries per second, right? So maybe it's, even if it's write heavy, the load is not huge, isn't it? So that is why the way I'm.
But I think like according to like what you said, like the master is the one which is scheduling the request, right? Like,
yeah, like taking the right
which
request.
means that like you can also have like high like 2 masters or 3.
Yeah, multi-master, right? Multi-leader. Yeah.
Like multiple masters as well.
Yeah.
So like it's like HA, like within masters.
Correct.
That's how you can do, and you can use some kind of sharing mechanism like storage.
Yep.
NFS storage to do.
See, instead of having a multi-master, okay, see what will happen if I don't have a multi-master. Okay, only thing is if the master fails, okay, so then whatever the current transaction is happening, it won't be happen, correct? But if I have, if my browser, okay, whatever I'm working on, again retries for that. If I have a retries mechanism, that
no,
master has to be up, like at least one has to be up, right? Like
sorry, I think someone is eating. Can you please mute? Thank you.
The master is up, should be up, right, to schedule the request. If the master is up, like no user can actually submit any like request. It can't unschedule compute nodes or like what? Slaves.
Availability is screwed in that case.
Okay. Yeah, makes sense. Yeah.
Yeah, I think in distributed systems, I mean, everything is possible. It's just about the
Right,
trade-offs,
absolutely.
right?
Yeah.
So,
I agree. But that's a good point, actually.
So conclusion is like, if it is a write-heavy system, we should go for the multi-leader, right? I mean, multi-master.
yeah, that's what I'm thinking. Yeah.
Okay. And if it's a read-heavy, then a single master and slave.
Well,
single master.
At least, yeah. In general, it depends. Yeah.
The only problem going with multi-master will be you will have more complications. Correct. It's going to be anyway.
So why not distributed databases in that case?
Usually partitioning is used when we have a write-heavy system, right? Like so, that is where the writes are basically partitioned across multiple nodes. So it's
that is
not
true.
exactly called as multi-master, but we still partition the writes across multiple nodes, right? So
no, partitioning will be definitely there in case of to distribute the load. But what I was thinking is, even if you have one shard, right, that is taking care of certain accepting certain writes, then talking about replication, right? I think in the replication context, I was thinking, should we have single master or multi-master? But I think it's a topic on its own. The moment you start talking about synchronous, asynchronous replication, it just expands. So,
okay, this is a good thing. I'll make a note of it. Surely it will be very helpful for me. Yeah, thank you. So
when we talk about multi-master or a multi-leader, is it in the context of sharding?
No, I'm talking in context of replication.
Okay.
Yeah.
When we talk
sharding
about
still always be there, right?
Yeah, sharding will be there.
But they here say we don't need sharding because the data isn't too much.
Yeah, that is what he's saying. But you can always have a discussion on trade-offs, and the interviewer might come back again. Right?
So when we talk about multi-master, right? So take an example of Postgres. When you have two different masters there, right? If you are trying to set up multi-master setup, then both of the masters will have the same data. It's just that when they are replicating. Okay, it's not sharding essentially. It's just two different masters, same data, async replication.
Sure. I mean, you're right. So in general replication, when we talk about independently replication, you're assuming that the data set is such that it can fit, like every node can host the whole copy of the data, right?
Yes.
And in that case, you're talking about, okay, single leader, multi-master, whatnot.
Yeah, so here, in this context, multi-master, which, two different masters keeping the same data set, async replication makes sense for dealing with writes.
Yeah.
Otherwise, you could choose distributed database where you will have sharding, of course. Say, for example, Aerospike is one example. Cassandra is another example, which is write-heavy optimized. We could use, and it automatically take care of your availability part. It is configurably available and consistent.
So you said multi-application.
So multi-master, when we talk about multi-master, right? By taking an example of Postgres, you have two different masters. They are async replicating from each other. You can configure them in such a way that only one master is taking all the writes and other master is just replicating, but is a host standby. Other way you could deal with this is both of the masters are accepting the writes. Now they need to deal with how frequent they are replicating from each other.
But if one master is only taking, then it's again master slave, right?
Exactly.
Sorry.
You are telling if two masters are there, one master will only take the request and
no, both will take. Both will take.
This can be configured in such a way that both can take and only one could also take. With single master and slave, you have to manually intervene yourself and promote slave to master. But when you are using hot standby, that guy itself will make itself master simply.
So selection of leader when a leader goes down is faster when you have such configuration. Okay. And I think multi-leader also. Oh yeah, go ahead, Shashank.
No, I'm saying, but when you said that only one master will take another, I mean, to the other it will be replicated, right? So that's again a master slave, typical master slave, right?
No, but he's still a master.
Yeah.
It's still a master. It can promote itself to being a master. You don't need to intervene.
Yeah. Got it. Yeah, and also
There's slight difference there, subtle difference.
Yeah. The multi-leader comes in when probably we have different database servers on different geographic locations, and you want to reduce the latencies. That's when you have multi-leader configs.
Yeah, so we can address that question when someone was talking about earlier, right? Yeah, it's not going to be solved that way, but at least to some extent, yeah.
I have one question here, Santosh. So after the challenge is over, so is there any cron job which is processing the score, iterating over the entire database? How would
yeah, that is actually for the leaderboard. Some cron job should run and actually get the results. That is what I'm thinking.
Okay.
Yeah, it has to happen, right? The event happens, and something has.
So it will iterate through all the submissions of a user. By the way, is there any capping on number of submissions that a user can make?
No, not really, but really required. Yeah, maybe even if he does it, because if you rate limit for him to submit any submission for a minute, something like that, so he can make maximum in an hour, maybe 60 submissions. So that might not be more, or maybe even if he makes every second 60 into 3600, still that should be fine, right? I'm just thinking loud, okay?
Right.
Now that would be like then intentionally somebody is trying to make the server down. Then only 3600 submissions you can make.
Yeah,
right?
so we can stop that.
Exactly.
Yeah.
I think there should be a rate limiter, right? Otherwise, it would be like unnecessary thing. Yeah.
Correct.
So yeah, I have a question regarding caching. Like when you talk about caching, like what kind of cache can we use on it is applicable? We have Redis and Memcache, right? So
so I would think Redis should be okay, isn't it? We don't need more specializations in that. So
Redis is actually highly available. Like Memcache is not like that high, not highly available according to my understanding.
Yeah, it's like a distributed cache, right? And it's highly available. And it's
both are distributed cache, isn't it? But Memcache has something more than Redis. I'm not very clear about that.
I think Redis has queue, stack, priority queue, all these options also.
Okay.
Same, I think there also you have in Memcache.
No, not by default. They are libraries that are on top of. Basically, it's string only in Memcache.
But
So
we can
if
take
you're
it. I mean, if required.
So if you're going to do request level caching, then Memcache will be much faster and also distributed. But if you have to store key value something, or maybe using some data structure, Redis is a more good option, I would say.
For key value, Redis is better, right?
JSON format.
Yeah. Okay. So now, as we said, the cron job actually can run this query for the leaderboard, and then get all the results. And then it can actually put that in a cache, and the other user can keep on accessing it. So if you now let's cover the other two small topics, what they said about code execution layer. And I think we did talk about it more. User containers on machine with high CPU. So that is what the containers will be. They don't consume too many resources. They will have appropriate privileges. And there will be a time limit set for each of these executions. So we get a time limit exceeded and all this stuff. And they talk about the plagiarism checks, So how do you detect that? So whenever we are done with this whole contest, we'll go through all the codes, submitted solutions, and take actions based on that. And they talk about some special softwares which are very good at that. I think it's the MOSS that is one which can actually post challenge.
Yeah. Stanford has developed one NLP software which is used for checking the plagiarism.
Okay. Yeah. So this is also one thing we need to do in our OJs. So it is at least it completes the requirement to some extent. Okay. And this was the reference article I was referring to, but I was going through some other stuff also around that. And I'll share all of this stuff in our Discord channel. Anyone has any other questions before we wrap?
Hey, I wanted to request if we discuss related to, having our user base split across regions
Recording
or maybe
stopped.
replicated across. Hello?
Go ahead.
Yeah, I mean, that sort of stuff, right? And then how your other services and their corresponding database are affected due to the decision that you take to store your DB, I mean, user related information in which region, sort of, right? I mean, that is helpful in case, say for example, Amazon, right? When you create your own account, but you can actually use it in US website or Singapore, I mean, whatever different regions they have, right? I could actually use that, but how do they control latencies? And the products are definitely different when you use, say for example, Russian website of Amazon, right, with that domain. The products are different, sure, but how are they maintaining the latency, and basically how their different services are impacted based on the decision that they take on user base? That is something we should be discussing also.
Okay. So see, what the way I think about it, if we have region based, okay, yeah, correct me if I'm wrong, and maybe you guys can add it. I'm just discussing and thinking loud. So what I would say is all these table will have to be replicated across all the regions. They will be separate, right? So every user will, for a particular region, will connect to that data center. Okay. So all those data, when he is actually competing for that particular challenge, all his data will go to that data center or that region. And when our on a very very simple what do you say, a simple design, if the whole challenge is complete at the end, okay, when then only we want to actually sync all the data. So we'll surely use a multi-master in that case, but the multi-master may be doing it periodic, whatever say the those synchronization between each and every region, but at the end when the whole challenge is done, so it surely has to do that, because now at that time the users or the write traffic is completely zero, so they can surely go and do all those, and at the end when everything is done, then only they can come up with the leaderboard. So one
There is
of the
another
data
challenge
center
here,
does
right?
that.
I am in US and I'm submitting in India. The latency will be there, which is too much, right? So you have to distribute your these evaluators to my region also, right? So
yeah. So the evaluation will be done at your place also, but then you will have to still aggregate all the data of all the regions together to rank all the individuals as per that score. Correct. So someone will surely have to do that. Maybe everything when the whole contest is done, so then there will be an aggregation service who does that, and that data will actually be again spread across all those regions. So from that particular score will be put on a cache, or maybe that will be accessible at that time only. So there will be some eventual consistency in displaying that leaderboard. That is what I would think. I know that we have not actually we should have designed it that way, but if that's not that done, then at the end we could say something like this. But yeah, others can add on that. Yeah.
No. I mean, I'm not talking about this particular questions concept. It is like in general that this is one of those things that interviewer usually ask.
Yeah.
In the last.
Exactly. Yeah.
And that is like screwing up your mind seriously. That
yes.
Why didn't you tell that before? Sort of. That is static content, right? This is not static content. This is totally dynamic.
Do we really need
CDN are never used for dynamic content.
So history is
Not-
immutable, right?
Basically, history, maybe, yeah, the comments and all that, that is fine, but for not for the contest. If we are just scoping our whole this one application only to just put the leaderboard at the end and just follow contest, then we don't need a CDN. That is what I think. But if we want to actually do practice problem that we do for Leetcode, then yeah, CDN makes sense, right? This is just my thoughts.
Yeah.
No, but that's a good thing to. I'll note it down and maybe sure we can have more discussions on it later.
But even dynamic content can be generated and delivered in from CDN CAS. You'll have to write explicit scripts for it. So somebody was mentioning that only for static. So that's not.
Yeah, actually, we do it for Netflix also, right? We have a CDN for those we
Exactly.
That is right.
Out there, the workers are there, right? JavaScript code they write, and then they can use it for dynamic content.
Yeah, so basically you can use CDN and like CloudFront, and you can point to S3. So whenever you update it, it can reflect that to the new content with dynamic.
Traditional CDNs used to be for static, right? But now that's not the case.
Again, AWS they keep on improving. Even I think Chavi is like mentioning about AWS Lambda, right? So like the startup times for AWS Lambda.
Okay.
So that's why. That is question.
Yep. So yeah, that is good. We had a good discussion.